Hi all, in this video we will solve the 21st question from Mechanical Engineering second set of question paper from GATE 2019. The question is, the state of stress at a point in a component is represented by a Morse circle of radius 100 MPa centered at 200 MPa on the normal stress axis. On a plane passing through the same point, the normal stress is 260 MPa. The magnitude of the shear stress on the same plane at the same point is. You can also refer to the NPTEL course Strength of Materials coordinated by IIT Roorkee. Before going to the solution, we need to know some basic data, basic information regarding Morse circle. What is a Morse circle? The transformation equation for a plane stress can be represented in a graphical form known as Morse circle. This graphical representation is very useful depending on the relationships between normal and shear stresses acting on any inclined plane at any point on a stressed body. Suppose in the left side you can see a body which is having different stresses on different planes. This is A, B, C, D. On the side AB, you have normal stress sigma y and shear stress tau xy. On the side BC, you have normal stress sigma x and shear stress tau xy. You can see from this that they both are perpendicular. That means both planes are 90 degree apart. So, how to draw this in Morse circle? In the figure AB, you have shear stresses sigma y and tau xy. Sigma y is a tensile force, which is a positive force, and tau xy is going in a clockwise direction, which is also positive. In side of BC, sigma x is positive because it is a tension, and tau xy is in counterclockwise direction, that will be in the negative direction. To draw a normal circle, first we have to draw a stress axis along like this and the shear axis perpendicular to that. Now first we will take AB. AB having both positive and positive, so that it will be lying in the first quadrant. And the sigma y will point the sigma y in the normal stress axis, and tau xy, which is a positive, and we'll do the tau xy and we'll mark this point. And later along BC we will mark the point sigma x, which is a positive value. Sigma x will be around, let it be this value, and tau xy is negative, so it will be in the downward direction. So this will be the point B. Okay, so this point corresponds to plane AB, this point corresponds to plane BC. Since the angle between these two planes is 90 degree, the angle in this Morse circle, it will be 180 degree, which is just twice of the angle. Suppose if it is 45 degree, then it would have been 90 degrees in the Morse circle. Later, pointing these 2 points, we will draw a circle whose the center will be on the normal axis. In the normal axis, and then with the radius either from this point to this point or from this point to this point, we will draw a circle. This circle is called Morse circle. And using this Morse circle, we can find the normal stress and shear stress at any plane. Okay, with this information, let us solve the question. In the question, it is said that we have given a Morse circle. So we'll draw a Morse circle. First we will draw the stress and shear stress axis, and it is said that it is centered at 200 MPa and radius 100 MPa. Okay, so what we'll do is that we will mark a point 200 and we'll draw a circle of radius 100. So if this is the circle and if you draw a circle, suppose if this is a circle, then this point will be 100 and this point will be 300 because the radius is 100. Okay. Now what we have to find is that there is a plane at which the normal stress is 260 MPa. 260 MPa means the point will be around here, 200 and 300, around 200, around this point, 260. And we have to find the magnitude of the shear stress. So the shear stress can be this line or this line, but this line is a negative. So what we need is a magnitude. So what we have to find is that this distance will give us the shear stress. But if this is 200 and this is 260, this angle, this length will be 60. Okay, since it has a radius 100, the distance between this point and this point will be 100. Now it is a right triangle, right? So we'll draw this right triangle. This is 60, this is 100. We have to find this angle, this length. So what is it? From Pythagoras theorem, it is nothing but 100 square minus 60 square. Okay, that will be 10,000 minus 3600. That will become 6400 and root of that is 80. Therefore, the magnitude of the shear stress is 80 MPa. The Mohr circle concept is a very important concept. With this, you can find the shear stress or normal stress, even the principal stresses using this Mohr circle. So, in this case, what will be the principal stresses? Principal stresses will be the stresses at which there will not be shear stress, right? So, the 300 and 100, they are the principal stresses. That will be sigma 1 is equal to 300, sigma 2 is equal to 100. Okay. Therefore, the answer to this question is 80 MPa. Coming back to the slides, the state of stress at a point in a component represented by a Mohr circle of radius 100 MPa centered at 200 MPa on the normal stress axis. On a plane passing through the same point, the normal stress is 260 MPa. The magnitude of shear stress on the same plane at the same point is. The answer is 80 MPa. For more clarification and reference, you can refer to the NPTEL course Strength of Materials coordinated by IIT Roorkee. Thank you.